Remember, I always come up here second block.
I figured you just walk through your good.
Yeah, I'm not a terrible people.
All right, so that's the Big Bang. Okay, any big deals? Any questions? Okay. Let's talk about the accretion theory. So we have the Big Bang, everything gets thrown out, right? And we have this thing called the accretion theory that starts with this planetary disk. Because as this stuff all gets spread out into the universe, and we'll see a model of this when we watch the video, we start getting these packets of energy that are centralized. In fact, the universe is not equally dispersed. We actually have some things that have more energy than others. So actually, it's kind of lopsided. And so when we think about a planetary disk, we start off with this sun. Here's our sun. All nice and bright. And then what we have is all this debris that surrounds the sun. Already.
She's never heard the story of the ghost of the year in high school.
Yeah,
The little kid that died.
the 3-week-old school.
It was built over the old school.
Actually, it was not built over the old school.
It was built close to the old school.
It's connected.
It was all over his face.
There was one construction worker that was buried alive in cement.
Are you being
Oh, yes. He fell in. No, no, seriously, he fell in, and they didn't realize that they just kept pouring cement.
And they noticed how.
I don't.
Yeah, they don't. Well, actually, once the cement sealed,
You,
they
the
got rid of
worst terrible liar I've ever seen.
And he actually blitzed me
No, I
half the time.
didn't.
No, you didn't.
I was like, I kind of did. I'm not sure.
But I was serious about that little kid that did die here. Justin, Patrick, Matt, we all know about that little kid that died here.
You said
Okay, we're moving on. Guys, hey, focus. So, we look at our planetary disk, gentlemen. And in here, we start seeing out of this cloud of dust, we start getting these larger pieces of material that start to form. And they all this is spiraling around that center piece, right? And this is, we call it a disk, because it's like taking a big pile of dough. You start spinning it like a pizza crust, right? And what starts to happen? It spins and it starts to thin out, right? Okay? Same thing here. Every time you start spinning something due to centrifugal force, it stretches it out. So this all starts to basically become a big circle. In this case, it kind of looks like an ellipse, which it should. Yeah, but it's circular. And so we get this little planetary disk. And then each one of these little rocks then start to have orbits around the star. Okay? And then this is what leads us to this thing called the accretion theory. Root word of which is accrete. What does it mean to accrete something? Or what does accretion mean? No? What you guys going? What does it mean? Accretion. You guys heard that term before?
Similar to intro. Similar to increase.
No. Think about concrete.
This is solid.
Seal, okay, somewhat. You guys do that?
Hard, it's fast.
No.
Great.
Okay. So the prefix con, or con, co, meaning what? Together. Together, right? So when we think about accretion, this is coming together. Right, so the accretion theory is how when things accrete. Basically, they're running into each other and they're fusing together. So it's when pieces of material are fusing together. So the accretion theory basically says that, in fact, I'm going to pause this here, because this is where we need to do our modeling. So I'm going to pause this. That is mass. And with mass is gravity. The larger your mass, the more gravity that you have. Okay, the more gravitational pull you have. So as these masses are basically colliding, as I described, they fuse together. So just as you guys are rolling around your Play-Doh planets, they're picking up the smaller pieces. They're fusing into one giant planet.
So are you saying that's how the Earth was made, or?
Yeah, so the Earth actually starts out as just a bunch of rock debris. But then as these rocks collide, they fuse together. And when they fuse together, they become larger. But when they become larger, their mass increases, which means that what else increases? Gravity. Okay. So as these things start colliding, they become larger, and they eventually clear a path. It's kind of the same thing when you got. How many guys ever made a snowman before? You guys have not made a snowman before.
Mine always fails.
So sad.
You are not.
You are not children.
You're not going to be chosen.
Hey,
I made an
stop.
igloo before too.
Now, so they eventually clear a path. Basically, if you ever made a snowman, right, you start with a single tiny snowball, and you start rolling it across the yard. And as you do that, it picks up the snow underneath it. And then your snowball gets larger and larger and larger. And eventually you start seeing the grass again. You start clearing your path from where you were rolling your snowball. But then eventually that ball gets really, really big, right?
Yes.
Okay? And so now, not only have we cleared our path, as I'm going to do here with my eraser, we've now cleared our path. That's a little weird. Okay. So I've now cleared my path. Okay. So now what's going to happen, now there's my clear path for my planet. But what happens now is because my mass is getting larger, my gravitational pull increases.
Here, that's just that head of
Exactly.
them. He was forklift. They're so delicious.
So gravitational pull increases as the mass increases. So now what I'm able to do with my planet is not just clear my path, but now I'm starting to pull in, you've got to think of it almost like a larger eraser. I'm now starting to pull in stuff from outside. So even though my eraser keeps going down to the center, I'm now pulling stuff away from the outer edges of my orbital path. And eventually, we have a very clean universe or solar system like we have today, where we have the planets, we don't have a lot of dust and stuff in between. At one time, that was really full of a lot of dust. But as the planets are moving around, they're kicking a lot of that extra dust. Okay, so it's not too bad. Okay, does that make sense? That's the accretion theory. Yes.
So if there's just like a random star, it doesn't have anything around it, like nothing orbiting around it, do you think if it was the accretion theory, it just wiped everything around it out and absorbed it?
Star. Okay, here's the problem. When we look into the night sky, we see this. There's just this bright light, right?
Yeah.
There's a star. It's all by itself. The problem is that's so far away. And again, you got to think about scale of what we're seeing from a very far distance. What we're seeing is the light emitted by this sun. That sun is like infinitely times larger than any of the planets that surround it. So we're not going to see the planets around that. Okay? If we could, you would. All these stars will have planets. In fact, when we do look out with the right telescopes, we can see they have planets. The way that we identify the suns out of the planets is if you keep an eye on the sun just long enough, it blinks.
The sun blinks.
Before you go
That's
blind.
unhealthy.
The sun blinks. And it's not, okay, why do stars twinkle?
The solar flares or something.
Because there's planets.
No.
It's
It's
that
actually
fast.
the air currents in our atmosphere. Okay, have you ever looked out across a long county road in the middle of summer? You start getting those waves okay, from the heat, and it disturbs the layer of the air above it, and it gets all turbulent, and that's how it distorts the light. Okay. Well, our atmosphere does the same thing to the star. It disturbs the light coming in and reflects it in all kinds of different ways, so it starts to twinkle. Okay. If you get out beyond our atmosphere, you get nice, clear, crisp pictures of the universe, which is the whole point of the Hubble telescope. I used to pose this question when I first taught the classes: why do we put that Hubble telescope out in space? And I love it because your first initial response is almost always the same: to get closer. Okay, and it almost makes sense until you start thinking about scale. That'd be like saying, I'm now closer to Indy. Yes, you are,
Technically.
but not worth mentioning. Okay? So, putting the Hubble telescope out in space does not put us any closer to getting a closer view of anything out in space. All it does is it eliminates the distortion due to the atmosphere. So we're able to view things. So with the Hubble telescope, they start looking at all these stars all the way around us. And what they're looking for is that slight blink. Just a little tiny blink. How many guys are not drivers yet? Okay. One of the worst things you guys will have to contend with as you become drivers is driving at night and watching out for deer.
Oh,
And that sucks. Well, no, not time for stories yet. Now, one of the ways that you can easily identify a deer at night, hopefully when it's in the middle of the road so you don't hit it, is when a car coming towards you, all of a sudden their headlights flash. Why would their headlights flash? Not like flash to bright, but why do they flash? What's happening?
something passed in front of us.
Something passed in front of the lights.
Or they
So,
go behind
how
you.
do we know that a star has planets? What are we looking for? Well, when it blinks. Why did it blink?
Plants.
Because a planet came in front of it. Not large enough to block out the light, but just enough to change the amount of energy that's reaching us. And that's that blinking. They actually identify planets based on that.
Wouldn't they see it for a longer period?
It's very, very short periods. But yes, they do see it.
So like,
Or like a blink lasts like 2 seconds? Or like,
And in fact, they usually need computers to sense the change. The human eye, I don't think is going to pick up on that change. They usually need sensors that actually will say, yes, that we definitely had a dip in the amount of lumens emitted by the sun.
could
All right.
solar flare or something weird from the star itself and mess with it?
Sometimes, but not always. And then if they get the right instruments with the right clarity, we can then actually show the transit of a foreign planet. Which actually, that's cool within itself. I know within this past year, it was the first time in over 50 years that Mercury, you can see the Mercury transit through the sun. It's really kind of cool. I mean, you can't see with your naked eye, you'll burn your eyes out. But, with the right telescope, so they can actually look at the sun, and you see this little tiny black dot move diagonally across
when
the
was
sun.
that?
That was earlier this year. I think it might have been the summer or something.
I think I was.
They're talking about, and it's kind of a big deal. We don't really see a lot of transits.
I got to Welling then to see if I can see that.
Like, in science books, when they show the sun, it's just like a whole planet.
Yeah.
They have telescopes where you can actually look at that, like,
Do Google search for images of the sun, and you will see it is different filters that looking at different wavelengths. And you can really definitely look at the ball of fire.
like you can see like fire and stuff.
Yeah, you can actually, and if you see it in motion, you can actually see it churning. It's really cool.
Look at it through Welling.
All right. So guys, we only have like 10 minutes left. I really want to get into this episode, so we're going to go to that next. And so what we're going to talk about next here are these 3 major theories that we'll get to tomorrow. But so we're going to go ahead and end it there, and we'll watch the video. I do have this video sheet for you guys to use. Do not lose it.